Okay, so someone very politely told me that I did not have a video for the calculator section, so let's rock through this here. All right, given a derivative, k prime of x, and an initial point, we can write an expression for k of x, I like these arrows, that involves an integral, and it is just this. This is how it works. You're basically plug and play here. So k of x is equal to, you start with the y value you know. Boom. Okay, except you know k of x has to equal that. And you add the change in k of x from 4, which is when we know it's 8.5, to x, where we want to know it. And the change is the integral of the derivative. So we put cosine. And it'd be super nice to put x squared right here, but we're not going to, because x is the integral, or the limit that we're integrating to, right? So we got to use a different variable here, and it's just that. Okay, and then step 2 here, number 2, says find the minimum value of k of x on a closed interval 0 to 2. Well, it turns out that we've already covered questions like this, and I know it seems a little bit different because we got integrals happening and all this weird craziness, but the way you find minimum values on the closed interval is, step 1, you find the derivative, and you find the critical values, right? And then you check those values and the endpoints. That's how we've always done this. So we know the derivative, it was given to us. K prime of x is just cosine of 2x squared. Now we know where that's 0. Now we have a calculator. We can solve that by hand if we had to, right? That's not crazy difficult. But we got a calculator, so why not? Just go ahead and do this on here, like that. So cosine 2x squared is my derivative. And I only care about 0 to 2, so I'm going to change my window to go from 0 to 2. You count by ones. And my y, I don't really care about what y is. I just want to see where this thing is 0, right? Technically undefined also, but cosine's never undefined. So I'm going to graph that from -1 to 1 on the y-axis, 0 to 2 on the x-axis. I'm just looking for critical values. Where's it going to be 0? So you see right there. And does it come back up? It does, of course. So we got 2, maybe 3. Oh, there's a third one. Okay, that was close. So we got to find those 3 values. Those are the possible mins or maxes. Mins in this case, what we're looking for. Actually, let's discuss this. This is the graph of our derivative, right? It's going from positive to negative at our first 0 there. That's going to be a maximum, right? We talked about that. If the derivative goes from positive to negative, that's a maximum. When it goes negative to positive, that's this one right here, that's going to be a minimum. What this graph tells me right here, even though we haven't gone through a ton of this right now because we're kind of moving quickly for virtual school, the derivative is positive until the first 0 right here, which means my function increases. And then it decreases until this 0 right here. And then it increases again to here, and then it decreases really quickly till the end right there. So we really only need that second 0. However, we're going to find all 3 because on the AP test, the way you're going to answer this is you're going to find all the zeros and just say that you checked what their values were. So we had second, trace, and we want this 0. And I can tell the first one's between 0 and 1, so I hit 0, enter, 1, enter. The guess, it looks like it's around like 0.9-ish, we'll say, and we get 0.88622, whatever, blah, blah, blah. All right, so we're going to write that down as an answer for this equation here. Now, for this test, you don't need to do all this. I'm showing you how the AP style does it. But we got to write 0.886227. I forgot our 8. What did I just say? 886227. 227. Okay, and I'm going to call that A. So that's one answer to that equation. Where's it equal 0? Right there. Okay. Now we know we have 2 others, so I'm going to say B equals and C equals. I'm going to find the other 2. So second, trace, equal to 0. And I know it's between 1, enter, and around like 1.6-ish. Looks like it's going to be there. There we go, that finds it. And it looks like it's around 1.5. So we'll guess that. And it's 1.53499. 1.53499. 1.53499. Okay? And I'm calling these A, B, and C. Actually, technically on my calculator, what I'm going to do, which I should have done this for the last one, after you get your 0 like that, if you quit out of here, as I'm showing you, go back to your home screen, and you hit this button, stow. It's right above on. It actually stands for store. I'm going to store my answers, what that says, as alpha B. And now B is stored as that number. So I don't have to keep typing it. I just use alpha b as that number. And I should have done that for a too. So I'm also going to put in my answer for a, 886227. I'm going to store that as alpha a. So now I can, on my calculator, just hit a or b, and that's going to be the numbers I want. And if we do c, let's find the third one. So second trace, here we go. One with a 0 between like 1.7 and the end of it, which is 2. And it looks like it's like 1.99 something. It's really close. So it's 1.98166. So before I get out of here, though, before I go and write that down, I'm going to hit second mode, which is quit, and I'm going to store that as alpha c. Okay? So those are my 3 critical numbers. Let's write that down. 1.98166. 1.98166. And technically, we got to take this all the way out. So 3649, we'll say 2. I know I didn't do that for A, but that's all right. 6 places of accuracy is pretty accurate for us. All right. Now, those are the possible places we can have maxes and mins. All right. So all I got to do is find k of 0, which is an endpoint, k of 2, which is an endpoint, k of A, which I can write, that's an A, by the way, in my scribble. Let me fix that, make it look a little nicer. K of B, which is going to be a minimum, right? And K of C, which is a max, but we're just going to find them all anyway. So the way I'm going to find this on my calculator, here we go, is you're going to type in, now, I've already got that derivative, cosine 2x squared, in my calculator. Y is y1. So I'm going to hit this, plus math 9, and I'm going to type in what k of x is. It's the integral from 0 to 0. So k of 0, we don't have to integrate 0 to 0. It doesn't make any sense. Oh, no, we start at 4. That's why. Okay, so 4 to 0. That's what we want. There we go. 8.5 plus the integral from 4 to 0 of my derivative, which is var's function, y1. Okay, so that was my derivative of x. And that's going to tell me what it is at 0. And it happens to be, calculator's working really hard here, 8.0233. 8.0233. All right, so we got that going on. 8.023. That's right, 3. Okay, good. Now we need k of 2. So rather than typing that again, I'm going to hit second, enter. That puts the same thing that I just typed, but I'm going to go back to that 0 and put a 2 in there because that's what we really want. And we get 8.5898. 8.5898. All right, and then we got to find k of A. So it's, again, second, enter. We're going to go back to that 2, and we're going to integrate to alpha A. And we expect this to be a maximum. This is going to be bigger than k of 0 because we saw the derivative was positive until this point. So it's 8.7144. 8.7144. And these really only need to be 3 places accurate. I'm not sure why I'm going to 4 places. That's just what I chose to do at this moment in time. Second entry. Go back and we'll find what B. Now B is going to be a minimum, but the question is it going to be less than k of 0? And it happens to be 8.3078. Okay, now what that really means, if you go back to our graph here, check this out. Kablow. That's our derivative, right? This positive area here is how much k increased from 0 to A. So it went from 8.02 to 8.71. All right. And then the area here, this negative area here, where it says drag screen for some annoying reason, that's a decrease in k until we get to B. All right. But the area in my negative region here is not as large as the positive area. So it went up more than it went down, is basically what it says. And that's why k of B is only 8.3 and not less than 8.0. K of C is going to be a maximum. We know that already, but we'll find it. I don't want to do that. I want to hit second entry. There we go. Then we'll go back here and we'll hit alpha C. And this is a little overkill. Like on the AP test, it's a little bit more straightforward for this, but you got to do the same process. It just won't be as many zeros. Usually, they don't give you that many. This is 8.5912. 8.5912. So again, to be redundant for this, we want to find the minimum of a function. The way you do that is you find the derivative. Then you find the zeros of that derivative, right? The critical values of k is what we're finding. And because we have a closed interval, we don't need to make a number line. We just find the value of k at the critical values and at the endpoints, because the only place a min can happen is at an endpoint or at a critical value. So it turns out the minimum is right there. So the way you'd answer that really, and this is just a review, so we're being a little sloppy here, but you'd write the min is k of 0. Whoops, I was going to do my 8 equals 8.023. So that's the smallest value. And this is really the minimum right here. All right, it's the y value. But if you put k of 0 equals, then you kind of cover all your bases. And that's that. 3 and 4 are very similar. It says find the minimum value of g. Okay, well, to find the minimum on a closed interval from 0 to 3, we derive it. So we talked about this today in class. G prime of x is, you plug in the top limit because you're deriving an integral. So that's the first part, where you plugged in x squared, and then you multiplied it by the derivative of x squared. Minus, we're going to plug in 2x, so that becomes 2x, the square root, 2x plus 3 times the derivative which you plugged in, which is 2. So you can put that here if you like. I'm going to simplify this up a little bit on my screen. So times the 2 back here, it really just makes this 2 here a 4. Cool. And this 2x back here times an x squared really is going to make this a 2x cubed. And I'm only doing that because basically I can, and I'm going to have to put this into a calculator, so I'm going to simplify it down a little bit. So that's what we got. All right, so the minimum value is going to come from either a critical value or an endpoint. So we got to find our critical values. Even though this seems crazy, we have this weird derivative, the process doesn't change. So I need to graph this crazy function, 2x cubed times the square root of x squared, right, plus 3, all right, let's not mess this up here, okie dokie, minus 4x times the square root of 2x plus 3. So we're going to graph the derivative, and now I only care about 0 to 3, so 0 to 3 on the x, and I care where it's 0 is all I'm looking for, so that's going to be my x values. My y values go from -1 to 1, because I want to see it go through 0, and we're going to graph that. And this is my derivative. Starts out negative, so it's decreasing. G is decreasing initially, and hopefully if I made this question correct, there's going to be a critical value. There you go, there's 1. So the derivative turns positive, so now G is increasing on that interval. And does it come back down, or is that it? Okay, it's done working. So there's only one critical value. All right, and it's right there around like 1.5-ish. So we got to find it. So second, trace 0, which is 2. It's between 1 and 2. Enter. And it's around 1.5, so we'll guess 1.5. And it is 1.465. We're going to store that. So second quit. We're going to store that answer as alpha A, so I don't have to type it again because I don't want to, because I'm lazy. 1.4652. So I'm going to run out of room here. I'm going to erase this over here. Get out of here, you. Chop. Okay, so we're going to write A is equal to, let's get rid of this A. We don't care about that anymore. There you go, not to be confusing. I forgot already, 1.4652. 1.4652. And then all we need to do, again, is look at the endpoints and the critical value we found to see which one is the max, or we want a minimum here, okay? So now I got to type in this whole thing, which is kind of a pain in the butt, but it's going to be math 9. We're integrating from 2x to x squared, right? But initially x is 0, so actually we don't need to do that. If x is 0, which is what I'm checking, that becomes the integral from 0 to 0. Well, the integral from a number to the same number is always 0. So g of 0 is just 0. All right, hope that's okay. That's just an easy one to find. If we plug 3 in, we get the integral from 6 to 9. It's important to note here, we're not plugging in 3 for t, we're plugging in 3 for x. X is what we're integrating to here, okay? Or it's defined, it defines what we're integrating to. So 6 to 9, and now we're going to plug it. Now on my calculator, I'm going to put in x's because that's the variable the calculator uses, but we don't need to worry about that. Okay, just it's really t, but we're going to put x in here, so it's x plus 3 dx. Let me get 73 0.1938. All right, that was g of 3. Now, the reason why it's happening, by the way, is go back to our graph. Remember we said, this is g prime we graphed here. It's decreasing, so it decreases a whole bunch, right? The area in here is negative. But then the derivative becomes positive, and you can see it leaves my screen. This gets really big. So it's a huge amount of increase happening here, and that's why g of 3 is a big positive number. So g decreases, and then it increases. Now we got to find g at a. So we're going to do the same thing we just did, math 9. We could hit second enter or math, with second entry and put the same thing here again, but I got to use this a thing, so I'm just going to type it again. But we have 2 alpha a. I'm going to go to alpha a squared. That'll work, right? That's the same thing. And then we have x, so same integral, second square root x plus 3 dx. Double check everything I'm typing here. Looks good, looks good. This should be a big negative number. It's not. It's just negative 4.689, but it's negative. Negative 4.689. All right, so again, let's go back to my calculator and explain what's going on. The reason why it's negative 4, so I thought it was going to be bigger than that, negative-wise, okay, bigger in magnitude. But this little hump here must not go down that far. If I change my viewing window, I think if I change my y min to negative 5 and the max to we'll go up to 50 for right now, okay? You can see it goes down just a very little bit, right? And then comes back up. So the area in that hump is negative 4.689. That's how much we decreased. But then it goes so far up, that's up to 50 right now, that the positive area is like 77 something. That's why it increases so much before it gets to 3. That's why g of 3 is so big. All right. G of 4 is the same kind of question. All right. We'll go from 1.5 to 2.5. We want to find the maximum of this function. So first step, find the derivative. G prime of x is the square root. If you plug in 5x, you will get 25x squared minus 2 times the derivative of what you plugged in, 5, minus the square root. If you plug in x cubed, you get x to the 6th minus 2 times the derivative of what you plugged in, 3x squared. That's g prime. I'm going to erase this. All right, so same thing. That's our derivative, even though, again, it seems really weird. And we just need to find out where's our derivative 0, because that's where maxes and mins happen, right? So we're going to graph this thing. So we're going to y equals, delete this out of here. And we need 5 times the square root of 20, nope, that's a 5, 25x squared, right? Yep, that looks good. Minus 2 minus 3x squared. I'm just putting the derivative part out front just because it looks a little nicer. Second square root of x to the 6th minus 2. There we go. Looks right. Double check. Make sure I didn't type anything incorrectly here. I think that's okay. And then we're going to graph it from negative 1. Or not negative, positive 1.5 to 2.5. Yeah, 2.5 is what we care about. Okay. And the same thing for y. All I care about is really negative 1 to 1 because I just want to see where this thing's going to hit 0. So graph. And then we just wait. There's 1. There could be more. It's still working. Well, what's happening? Circle's still spinning. There we go. All right. So there's only one critical value, and we can see our derivative is positive until where the 0 is, and then it's negative after that. So that's going to be the maximum. What that means is my function moves upward until whatever this x value is, and then moves downward. So that has to be the max, but we got to find the x value there. So second calc, we want the 0. You know, it's between 1.5 and 2. Looks like it's around 1.7. You can just hit enter here too. I like to guess to see how close I can get to what it looks like, which is nerdy, I know. Well, we get 1.7108. But before I do anything, I'm going to go ahead and quit out of here. And then store that as A again. Kaboom. Okay, 1.71085. So we'll write for this A equals 1.71085. I think that's right. 71085. Yep. All right. And then same thing. We got to find G at our endpoints and G at our critical value, which again, we already know the critical value is going to be our answer because our derivative was negative and then positive. So G goes up and then down. So our critical value is going to be up here is what we're looking for. All right. But we got to plug this in. So this is probably a little overkill doing this here, but we got to plug in 1.5. Hoi. So we need 1.5 cubed to 5 times 1.5. That makes sense. Of the integral here of the square root. There we go. Whoop, wrong thing. Clear that out of there. Delete. No, get over there. Delete that out. There we go. Nope, delete that too. There we go. Second square root. There we are. X squared minus 2 is what we're doing. So x squared minus 2 with respect to x. Boom. It's 21.613. We also need that at 2.5. So again, rather than typing that again, I'm going to hit second enter. I'm going to go all the way back here, and I'm going to change my 1.5s to 2.5s. There we go. Enter. We expect this to be big negative number. Yep, negative 43.722. We expect it to be A to be our maximal. So we're going to hit second entry. And second, the arrow puts you back at the beginning again. It's kind of like the home and end key on a computer. But we got to put A into here, right? So, oh man. I stored that as A, right? I'm going so quickly, I'm not paying attention. Alpha A, I did store that, right? 1.71, okay, good. I just want to make sure. All right, so now we did second enter again. There we go. I just want to double check that I stored A before I just started typing in some random nonsense. Alpha A is here, A cubed, to 5 times, delete, alpha A. Looks good of that, and this should be something bigger than 21, 23.507. All right, and we're just going to say the max is 23.507, and we should say G of A, and you're allowed to say that because we defined what A was somewhere on our paper. So that's it. Okay, I didn't do that for the last question, by the way. I should have a little sentence there, but that's okay. All right.